Hi, my name is Vince Nguyen. I'm currently a master's student in computer engineering. Graduated with a bachelor degree in EE in 2015. I'm currently working for a power utility in the Midwest. I am here to present my project presentation in my attempt to tackle the house prices, advanced regression techniques, computation, and Kaggle. My main goal in this project is to apply the techniques I learned from the engineering management course 6413, Advanced Engineering Management Science, taught by Dr. Canfield at Missouri S&T in spring 2021 semester. So the content of this presentation are goals. What do I plan to accomplish in this project? Workflow. How am I planning on addressing these challenges? And the results that coming out from this project. And the future work, what can I do to improve the model? The expected outcome of this competition is simple: develop regression prediction model to obtain the desired outcome, which is the determine the best model with the lowest root mean square error. This data set was provided by the Amos City, Iowa Assessor Office. Mr. DeCook were exploring the alternative to the Boston housing data set to be used in his regression project. The dataset contains a mix of nominal, ordinal, continuous, and discrete variables using calculation of assessed values and included physical property measurements in addition to computation variables using the city's assessment process. Observation of this dataset was directly obtained from the real housing sales data at Amos City, Iowa, between 2006 and 2010. There is no mentioning of randomness sampling in this dataset. This was simply understood as all value obtained from the city officials. Since this dataset is limited to Amos City, Iowa, it should be used toward prediction for the city only. So the workflow of this project consists of three major steps: exploratory data analysis, EDA, and data preparations, which is the first step, to perform initial investigation on data to discover patterns, to spot anomalies, to identify appropriate input variables to the regression model, and any data transformation needed by using summary statistics. Next, data cleaning is performed to transform our dataset to better fit the regression model. The second step is literature review. In this step, I reviewed the IEEE literature research database to identify work that has been performed on similar projects so I can apply on this project. Thirdly, modeling and predicting the outcomes. I'm going to build the model and compare the root mean square error value between the models. So EDA, let's look at the overview and structural of the dataset. The summary combined train and test dataset as shown in this slide, which contained a total of 19 observations. There are two types of variables: 38 numeric or integer variables and 43 text or character variables. Most of numeric integer variables provide quantification characteristic of the properties. Example are lot size, dwelling square footage, etc. Other numeric integer variables are discrete, which typically quantify items inside the property. Example are number of bedrooms, bathroom, etc. Text or character variables are generally descriptive variables, which provide different categorical value of these variables. Examples are types of garage, material, environmental conditions, etc. Two data transformation was done to address the missing value and predictor skewness. And so in this plot, the predictor variable sale price seems to be skewed to the right. The normal QQ plot, you can see that is the outlier are deviating away from the feed line. So for data cleaning, the left picture shows the variable with missing values and how many there are. Most of the missing value in general were replaced with either none or zero. This is based on the review of all variable description. There is no existing value representing none or zero. In addition, all data type are either numerical or factors. For numerical variables, missing value can be interpreted as not available. Example R, this house contains garage with 1, 2, or 3 cars. Since there's no garage with 0 cars, it is appropriate to interpret missing data as 0. For factor variables, similar philosophy can be used. There are few variables were replaced with median values. I chose this approach due to median or mean are fairly standard within the upper or lower standard deviation. Therefore, it is fairly reasonable to use the median to not skew the data. For the predictor value, the frequency and QQ plot are shown in this plot. Sorry, missing the slide there, but I was mentioning that the new QQ plot was has shown the improvement based on log transformation, which was performed on the predictor variable in order to optimize our linear regression model. So, in the literature review, here are the 3 papers that are related with this project. In summary, these papers have the same goal, is to predict the future house pricing based on historical data. The authors perform model comparison between various regressions, classification algorithm based on previous conducted research. All papers concluded that using methods to strengthen the weak learners to turn them into strong learners has improved the root mean square errors. This method is similar as the gradient descent boosting algorithm. The project workflows are similar with normal data science process. Different data set were utilized, however, using the gradient descent boosting technique were used on all 3 variables, which all 3 data sets were shown the best root mean square error on all 3 papers. In conclusion, I plan to perform the linear regression model in this project, as well as the gradient boosting technique. The evaluation approach will utilize the root mean square error to compare the implemented model. Next would be linear regression. In summary of my linear regression model is shown on the left. This model used the most 3 correlated variables without predictor sale price. These variables were analyzed and shown in the 2 plots in this slide. Only 3 variables were used due to it was running out of time to analyze the fitted of other variables. All the model statistics shown on the left seem to be reasonable with the obtained root mean square error of 0.17 approximately. Next is the Lasso regression. It stands for least absolute shrinkage and selection operator. This model uses the shrinkage method where the extreme values in the sample are shrunk toward a sample mean value. The tuning parameter lambda controls the overall strain of the penalty. Caret cross-validation was used to find the best value for the lambda, which is the tuning parameter for the Lasso model, as shown in this slide. Lasso has an auto variable selection function to identify the most correlated variables, and as a result, the Lasso model was ran, which shown that it handled the multi-collinearity, which is another word for the predicted skewness, as shown earlier. It's handled the situation very well by using the 27% of the variables. The root mean square error for this model was obtained approximately 0.11. Next, we are going to talk about the XGBoost model, which is simply stands for Extreme Gradient Boosting Model, which XGBoost is a preview R package available. As described in previous projects or in the literature review sections. The gradient boosting method was recommended by various research projects to be used in house sale price predictions. This model is similar to gradient boosting framework, but more efficient. It has the capability to do parallel computation, which provide faster computation than the original gradient boosting, hence the word extreme. Cross-validation was performed for parameter tuning using the fivefold cross-validations. The best root mean square error for this model was obtained at 0.118 after approximately 278 iterations. So the root mean square error comparison is shown below, or shown on the left. In summary, the three models has performed fairly well. As a result, the lasso and XG boost regression models show approximately 6% increase in RMS root mean square error value, which represent better model in compared with linear regression, which show a better model than the linear regression model. However, the lasso model show a slight improvement, about 0.5% when compared with the XG boost model. For future prediction, it is recommended to use these two models in conjunction for comparison on different data sets. So for future work, I do plan on going back to the linear regression model to work on the identify other fitted model to build into model. I only use 3 variables in this project, which I do plan on improving that in the future when time available. So, and in addition to that, the root mean square error seems to be approximately 11%. We'll also look on other research projects to identify any kind of improvement on these root mean square error value on these two models as well. So those are what I do plan on to do in the future to improve my projects. And that will conclude my presentation. If you have any suggestions, please let me know. You can contact me via Canvas or just simply send an email. Thank you very much for your time, and that will be all of my what I want to present. Thank you.